Welcome everyone. My name is Oliver Kirstebaum and I'm the Senior Staff Scientist on the MERIDIAN project. And on behalf of the MERIDIAN team, I'd like to welcome you to this third webinar in a series of 7 webinars that we're hosting this winter. MERIDIAN is a 3-year project funded by the Canada Foundation for Innovation. We also receive support from the member universities, which include Dalhousie University, Université du Québec, SFU, UBC, and UVic, and also a few industry partners, notably JASCO and Exact-Earth. This webinar series in particular is funded by a grant from DFO under the Ocean and Freshwater Science Contribution Program. And finally, I'd like to acknowledge Pisces Research Project Management, Kieran in particular, who is with us here today, for their help with preparing and running these workshops. So at MERIDIAN, our mandate the last few years has been to support the ocean research community through the creation of software tools for managing, analyzing, and visualizing underwater acoustics data. And so as part of this webinar series, we will be showcasing some of the tools that we have been working on in the last couple of years. Today's webinar, which is given by MERIDIAN staff Jordon Johnson, motivates and discusses the use of visualizations in preference inspection and describes our recent work in identifying the relevant analysis tasks and developing software tools to support the preference inspection process. The webinar is being recorded and the video will be made available through our YouTube channel within the next week or so. And here you can also find recordings of the past week's webinars, which were about underwater soundscapes and fish sounds. The recording of the webinar about fish sounds is not out there yet, but will be uploaded soon. So that ends my little welcome speech and introduction. And so without further ado, I will pass on the microphone to you, Jordon, and you will be in charge from here. We're scheduled for this to last a little under an hour, so we plan to finish by 3 p.m. This is local time here in Halifax, and that would be 11 a.m. your time, Jordon, on the West Coast. Yeah. Anyway, I'll stop sharing my screen and then you can start sharing yours.
Okay. Let's just get mine up here. That's not it. This is it. Let me just get my own started here. Oops. There we go. Can everybody see that okay?
Yep, looks good.
Okay, excellent. So thank you very much for attending this webinar on visualizations for preference inspection and group decision making. As said, my name is Jordon, and this work is done in collaboration with Emily Hindelong, who is the lead author on the paper we published on the subject this year, Giuseppe Carinini, and Tamara Munsner. So before we talk about the work, let's motivate it a little bit. First off, group decision making is everywhere, quite literally. Whether you're talking about something as simple as a family choosing where to go for dinner, to something a bit more complex, a software company choosing a technology stack, or university department hiring new faculty, to even larger scales, countries selecting sites for new marine protected areas. These group decisions are a part of our human fabric. And as well as varying wildly in terms of scope, these decision scenarios can vary considerably in both complexity and impact. So in a number of ways. So they can vary in the numbers or diversity of alternatives. Maybe we're dealing with a decision that has just a few alternatives that are quite similar to each other, or maybe quite large numbers of alternatives that are wildly different in a number of ways. And in these attributes, we have variance as well in terms of the numbers of attributes that may need to be considered, as well as their importance. So, for example, if I'm choosing a hotel, I don't really care whether or not the hotel has a pool, but it had better have Wi-Fi. Our scenarios can vary in terms of the numbers or the diversity of the stakeholders. Are we dealing with a small group of stakeholders that essentially have the same interests? Or are we dealing with large numbers of stakeholders that potentially come from quite varying backgrounds and have varying interests as a result, and so on and so forth? That there is a lot of complexity in this domain. But one thing that is common to group decision-making is the group, so people. And when you have people, you can have interpersonal challenges. And one of those interpersonal challenges is obviously disagreements. And so we need to ask ourselves, what are the disagreements actually about? Are we talking about just differences of opinion? Or perhaps one or more of the stakeholders is missing a bit of information that they would be able to, if they had that information, they would see things in a whole new light and have completely different preferences. Related to that are misunderstandings. Are we having these disagreements because decision makers perhaps don't properly understand other people's preferences to begin with? Or do they even understand their own preferences? We can have assumptions and we can have biases that affect our own preferences without even really knowing it. So the questions we want to ask in order to motivate our work are, first, what is preference inspection, and why can it be beneficial to effective group decision-making? Second, how can visualizations support the preference inspection process? Next, are visualizations, are they all equally effective? And if not, how can we make sure that we are designing effective visualizations? So hopefully the motivation will answer these questions for you. So first question, what is preference inspection? Well, it is part of preference elicitation and inspection process. So first, we have our stakeholders explicitly model their preferences over the alternatives. And this can be done in a number of ways. We'll use the example of choosing a hotel again. We can use simple numerical scales, like a scale of 1 to 10. I score Hotel X an 8 out of 10, but Hotel Y is only a 4 out of 10. It's one way of doing it. Another way that's known in the literature is called the paprika method, where you elicit people's importance in terms of the attributes. So, for example, you ask a question, would you rather have great Wi-Fi and no pool, or would you rather have a huge pool and no Wi-Fi? You ask questions like these over and over again to get an understanding of how much each stakeholder values each attribute of the alternatives. And there are other ways as well. But once these preferences have been elicited, then decision makers are able to examine or inspect those preferences in order to determine how the alternatives perform, in order to identify and investigate sources of disagreement, and hopefully through discussion, come to a better understanding of everyone's points of view. Now, this should be an iterative process. This eliciting and inspecting should be done repeatedly, because if a person through introspection while performing preference inspection, if that person comes to realize that maybe their preferences need to be adjusted, then that is a re-elicitation of their preferences, and we can begin the process again, hopefully to iterate towards consensus, or at the very least, to a more thorough understanding of everybody's positions. So, in order to ensure that this process of preference inspection is effective, it is vitally important to gain insights quickly. We don't want to be spending a whole lot of time trying to figure out which hotel Jordon likes best. We should be able to make it quite obvious which that is, so that we can get into the more meaty stuff of discussing the preferences and the underlying reasoning. Unfortunately, this can be difficult to do if you're dealing purely with text-based formats. So, for example, here we have 5 people who are just scoring on a scale of 1 to 10 a number of different restaurants. And even though this isn't a very complex scenario, it can still be hard to just automatically glean too many insights from this. So, for example, if we take a look at Alice's scores, well, we can look at it and we can see, yes, her highest score is Pizza Hut, and that's not too difficult to do, but we're having to cognitively go through the scores in order to come to that assessment. Whereas If we use a visualization, so this visualization here, it's quite obvious that the Pizza Hut bar is the longest one, and so we infer that that's Alice's highest score. So visualizations leverage extra hardware in the human brain, so the pattern recognition and pre-attentive capabilities of our visual systems. So visualizations can actually be quite useful in helping us glean these insights quickly. However, we need to be careful because not all visualizations are equally effective. So here I'm comparing two values, and I'm using three what are called idioms to do it. And you can very roughly just say idioms are ways of representing information. So here we're using bars that are arranged in a particular way. And it is quite obvious that the purple bar is longer than the gold bar. And not just that, we can be quite confident that the purple bar is about twice as long as the gold bar. That's quite obvious to us. Now, it is significantly less obvious, although we can definitely tell that the purple circle is larger than the orange circle. It's not at all obvious that the purple circle is twice as large. And that's because we're able to process certain visual inputs more precisely than others. So we're able to assess length more precisely than we're able to assess area. Now, just because bars seem to work better than circles doesn't mean that bars always works perfectly. You also have to take into account things like how you're arranging these bars. So in this case, for this third idiom, we're back to using bars again, and it still is obvious that the purple bar is longer than the orange bar, but it's no longer obvious that it's twice as long. So it's important to choose idioms that will be effective in supporting the tasks that we're trying to accomplish. But in order to do that, we first need to understand what those tasks are. We need to understand what it is we're trying to accomplish here, because a visualization is not guaranteed to support all tasks equally well. In this case, I've just got a visualization of 6 different alternatives, A, B, C, D, E, and F, and we're measuring total score. And total score, you just take everybody's individual scores and add them up. There's different ways you could do that, but that's what we're doing here. So if we're asking the question, which alternative has the highest overall score? Well, that's easy. It's B, because that's got the longest bar. For total score, not a problem. However, if we're asking which alternative has the most disagreement around it, well, this visualization tells us nothing about that. And even if it did give us some indication of that, it's not saying what the source of the disagreement is. Are we dealing with perhaps most people agreeing, but we just have a small number of outliers? Or maybe are we dealing with polarized groups, Team Hotel X versus Team Hotel Y? So this visualization is telling us nothing about that. Another thing to consider is, well, which alternative does the majority shareholder prefer? Because we're not guaranteed to have all shareholders be equally influential in making our decision. So we need to take into account, we want to be able to generate visualizations that support all our tasks as well as possible. Now, one solution might be, well, if a visualization can help us gain one insight, then why not just have lots of little visualizations, each targeted for a different task? Well, that sounds like it could work. However, there's a problem in that switching between views, between visualizations, can increase cognitive load. So let me give you an example. We still have this same visualization here for total score. B is the highest total score. Now I want to consider disagreements. So let's do another bar chart of variance. So we go ahead and we do a bar chart of variance. And we go, okay, B is pretty low in terms of variance, so not necessarily a lot of disagreement. But C has the lowest variance. So we seem to have the most agreement about C. But now I don't remember what the total score for C was. So now I go back, oh, C's not doing too bad, but now I'm having trouble remembering about any of the other variance values. And so this idea of cognitive load, having to store in memory the contents of other visualizations, can be quite problematic. So having a whole bunch of targeted visualizations isn't necessarily a good idea. So how do we come up with an effective visualization system. And a way that is strongly supported in the literature is called the nested model of visualization design, which is a rigorous and domain-independent framework for designing and assessing effective visualizations. So we start out, and it's a nested model because the output of a given stage serves as input to the next. So we start out by making sure that we understand the domain that we're dealing with as well as possible, and what it is we're trying to accomplish with the visualization. Once we understand that as well as we can, then we move on to the data and task abstraction phase. So basically, this idea of shedding everything that is specific to that domain by asking, so for example, with data abstractions, are we dealing with data, are we representing data that can be shown as a network, or can it be shown as a multidimensional table? So this is an abstraction that allows us to kind of shed some of the specifics of the domain while retaining the essence of the data and tasks that we're trying to do. Once we've done that, then we can go, okay, well, what visual idioms, so whether it's encodings like bars and circles or interactions like sorting, what idioms are useful for representing that data and facilitating those tasks. And once that's done, we move on to the algorithm stage where we do implementation, obviously. All right, so that is the model that we follow in our work. We follow the model of nested model of visualization design. But before we get into our work, I've just info dumped a bit, so I think it would be a good idea to have a bit of a question break and see if anyone's got any questions about the problem and the concerns as I've outlined them. Feel free to type, or if people are able to unmute?
Yeah,
okay.
People can unmute if they have questions, they should be able to.
Emily says, love the visuals. Thank you very much. I appreciate that. I'll give everyone a minute just in case people are typing. Excellent. So the paper was already shared. Good. I've got the references on the slide at the end as well, so hopefully that'll be useful to you as well. Yeah, all the references I'm dealing with. All right. So hopefully this means that everything's been clear so far. So I'll go ahead and move ahead. Feel free to keep typing. If you do have a question, I don't mind pausing to answer questions. It's fine. All right. So our work, as I said, follows the nested model of visualization design. But since group decision-making is still not a trivial domain by any stretch of the imagination, we begin with the simplest case where we are scoring alternatives directly. And that is the focus of the paper that was just linked here. We do also have ongoing work where we extend this to more complex preference models, but the bulk of this will be discussing our work for scoring alternatives directly. I've got the nested model up here in the top with the relevant section highlighted, just in case you're wondering which part of the nested model we happen to be in at any point. So, of course, we begin with the domain situation. And since there are so many domains that can be applied to group decision-making, in order to understand group decision-making as a whole, we want to have a variety of real-world scenarios that we look at so that we can try and get domain-independent features of group decision-making. And so that's what we did. We chose 7 very different scenarios, from something as simple as choosing the best paper award for a conference, choosing candidates to hire to a faculty department or to a university faculty, to again, software companies choosing a technology stack, to things like choosing a strategy for a nuclear crisis, or even scientists choosing trajectories for spacecraft that will travel the solar system and beyond. The scenarios vary wildly in terms of domain, but they also vary considerably in terms of how many alternatives are being dealt with. For Voyager 2, Voyager 1 and 2, we had dozens of alternatives. For picking a technology stack, there were only 2 in the case we looked at. And similarly, the number of evaluators can vary from just a handful to dozens. In addition to these what we call structural features, there are a number of other features associated with the decisions we looked at, including what the stakes were. So very high, obviously something like launching a spacecraft would be considered something very high, or responding to a nuclear crisis would be considered very high. What the work context is, whether we're just dealing with a casual decision, or perhaps something that affects a company, or something that requires the assistance of people who are experts in decision-making methods. The time frame, are we going to take days in order to discuss and come to a decision on the matter, or is it just going to take hours or even perhaps minutes? And then also the decision frequency. So is this a one-time decision, or is it something that we know we're going to need to do repeatedly? So for example, faculty hiring tends to happen on a yearly basis. From these features, we were able to come up with 3 overall user classes. So casual, kind of self-explanatory, professional as well, and then specialized is the case where you would definitely need to have people with expertise in decision-making. So now we move on to data and task abstractions, now that we have an idea of the domains that we're dealing with. And so we chose to represent the preferences that are elicited as tabular data, so multidimensional tables. Now, a multidimensional table is going to have a number of dimensions. In this case, we have 2 dimensions. We have the alternatives. So in this case, we've got restaurants here. And then we have the evaluators, the people who are scoring the alternatives. And we can use these dimensions in order to form keys for key value pairs. So for example, we can look at Bob's preference with respect to A and W. We see that he scored it an 8 out of 10. And so these values are examples of what we call a measure. So we take the alternatives, we take the evaluators, and then we could obtain the measures, which are, in this case, dealing with scores or ranks. So if we're scoring the alternatives or if we're ranking them. And so we alt score, alt rank, alternative rank. And so we obtain these measures. And then we can derive additional measures from them. For example, total score is derived by simply adding up all of the individual scores for the different evaluators for a given alternative. So the total score for McDonald's, if I were to add that up, 20-ish. Oh, maybe closer to 3. Anyway, so we move on. So that's our data abstraction we're representing as multidimensional tables. For task abstractions, we want to go a little deeper. And before we can come up with abstractions for specific tasks, we need to find those tasks. But in order to get those, we need to find some scenario-independent goals. So goals that apply to group decision-making as a whole. And there were 5 of them identified. First, to discover viable alternatives, obviously. To discover sources of disagreement. To be able to explain individual scores. To validate the preference models. And then finally, to discover nuances that aren't captured by the current preference models. So we'll notice that these 5 goals, some of them have sub-goals. So for discovering viable alternatives, we may be interested in discovering high-performing alternatives across all evaluators, or maybe just for a particular evaluator. So we have this hierarchy of scenario-independent goals and sub-goals. And once we have those, we're able to identify analysis tasks that support those goals. So we identified 12 such tasks when it comes to scoring alternatives directly. And as we note, 6 of those 12 are for the first goal, so, for discovering viable alternatives. So things like discovering alternatives with the best total score, discovering alternatives with low variance in the alternative scores, discovering non-dominated alternatives. So non-dominated simply means there is no other alternative that anyone has scored higher. Discovering trade-offs, discovering pros and cons for a particular alternative. And then this one is interesting in that we're back to discovering alternatives with the highest score, but this time it's the highest alternative score for one evaluator. But we notice that this task is actually quite similar to our first task, with the only difference being that here we're aggregating overall evaluators, whereas down here, it's simply a matter of finding the best score for one evaluator. So this similarity suggests that these analysis tasks can be broken down into more fundamental tasks associated with visualization. And these are they. So we call them auxiliary task functions. And we have a number of them, various kinds of tasks to compare, whether it's comparing a pair of values, comparing distributions, summarization, browsing, various tasks associated with visualization. So to give an example of how a task can be made up in terms of these, let's take the example of we want to compare Alice's preferences to Bob's preferences. So that's an analysis task we want to do. And so in order to do that, we first need to be able to locate Alice's preferences. So this is a search locate task, and we're only doing it for one evaluator, Alice. And so once we're able to locate her tasks, or locate her preferences rather, then we want to be able to locate Bob's preferences, again, using this same visualization task. And once we've located both of those sets of preferences, then we want to be able to compare them. So it's the compare task, and in this case, over all alternatives for those two evaluators, Alice and Bob. So all 12 of the visualization or the analysis tasks that we talked about can be broken down into sequences of these auxiliary task functions. Now that we have these data and task abstractions, we can move on to selecting the proper encodings. And so the way that we did that was taking a number of core idioms, so things like strip plots, bar charts, heat maps, and evaluating them in terms of those auxiliary task functions. So those 10 fundamental tasks I showed you in the last slide. So for example, if we're trying to compare the two values, Bob's scores for, say, Fairmont and Days In, well, this strip plot, it's quite easy to tell that Bob prefers Days In to Fairmont because the Days In circle is to the right. It's quite obvious. Now, it's somewhat less obvious in general if we do a strip plot where now Bob doesn't have a strip all to himself anymore, but the strips go with the hotels. In this case, it's still fairly easy to tell because the strips are close to each other for Fairmont and Days In. We can still see that the Days In circle is to the right of the Fairmont circle, but if we had a bunch of hotels in between, then it would be harder to be able to tell which one is to the right. Not impossible, but still harder. Similarly, for something like a heat map, in this case, since they're right beside each other, it's quite easy to tell that the Days In is a darker color than Fairmont, but if you spread them apart and have a whole bunch of colors in between, it can be quite difficult to tell which one is darker. So we performed this for all of the idioms that we looked at, for all of the auxiliary task functions and all of the possible cases for each of the auxiliary task functions. And so we scored them on a 0 to 3 scale, 3 being the best, 0 being completely ineffective. And we noticed something interesting. So we noticed that there are some there are some of these idioms that do quite well at a number of tasks. So this parallel coordinates is the best at 5 different cases. However, it's also not very good at some other ones. And that's one of the important things to see here, is that there's no one idiom that strongly supports everything. However, there are combinations of multiple idioms that can be used to strongly support everything. So what we can do is we can take a selection of these idioms and combine them into what we call a multi-form design. And so this is one example of such a multi-form design, and this forms our recommendations for casual users. So we have a tabular bar chart here with in this case, the hotels on the left. Oh, I should mention at this point that these aren't actual preferences. The people are fictitious. We're not making any statements about relative quality of hotels. So don't worry there. We're not stating anything. It's just random stuff that we threw at it. So we have this tabular bar chart, and the tabular bar chart is supplemented by a stacked bar chart. So we can take a look at people's preferences individually. We can take a look at Bob's, Carol's, for example, and we can also see the aggregates and how they compare to each other. If we're interested in seeing distributional information, we supplement the tabular and the stacked bar chart with a box plot so that we can get an idea of the variance and the differences between best and worst. Right. Now, for more advanced users, because as I mentioned a couple of slides ago, that parallel coordinates plot did quite well at a number of things. So we want to be able to leverage that power. So for more advanced users, what we recommend is 2 different comparison modes. So when we're comparing evaluators, let's go ahead and use the box plot, and it's able to give us the distribution of evaluators for a given alternative. But when we're comparing alternatives, we'll switch things up and use a parallel coordinates plot where each evaluator gets a strip all to themselves. And you'll notice that we're using 2 different color palettes here. That is by design, because we don't want to have the same color, say, for Anne here, or for Fairmont here, as we have for Anne over here, because then people would be conflating certain evaluators with certain alternatives, and we want to avoid that. So with this in mind, with this recommendation for advanced users, we went ahead and we developed a prototype. And that prototype has a number of features in addition to what we discussed. The first being the ability to get additional information on demand. First, in terms of numerical overlays, you'll see a number of little boxes here with numbers, because even though we're trying to do things visually, it's still useful to be able to have the numbers if we want them. We can get additional details on demand at any time here. Whenever a user hovers over a particular circle or a particular bar, then this pane appears and displays all the details that we have about the score that's being represented. So the name of the evaluator, obviously brushed out here, the name of the alternative, and in this case, the alternatives were papers in natural language processing, so that's the title of the paper. We have the score that was assigned by the evaluator, and we have any comments provided by the evaluator in order to justify their preference. So we provide these details on demand. And as we said earlier, it's really important for the elicitation and inspection process to be iterative. So while people are assessing the various preferences, they may decide to change some of their own. So we provide a means to do that. And submitting these preferences updates the information on our servers, and it broadcasts to all concurrent users. So if you're having a discussion with people far away and you're looking at the same decision, when you update your preferences, they'll be able to see that right away and take your changes into account as well. We obtained preliminary evidence of utility with 2 user studies. The first was with MERIDIAN staff, who were very accommodating. And the second was with the natural language processing group at UBC Computer Science. And there are a number of conclusions that we drew from this, a number of insights that we gained, but I'll just take you through a couple of them. First, we note that while most of the visual elements were rated quite highly, an exception seemed to be the parallel coordinates plot, even though, as we said, it quite strongly supports a number of the tasks. We suspect that this low score is partly due to the corresponding lack of experience. So this here, the 1.83, the 1.75, indicates that the participants for both studies weren't terribly familiar or, well, had no previous experience with the parallel coordinates plot, so it's a fairly new idiom for them. And similarly, switching between comparison modes necessarily means switching to the parallel coordinates plot. So while there still may be some way in which the parallel coordinates plot is less useful, we suspect that these scores were due to primarily to the lack of experience. It's important to note also that every single participant in the MERIDIAN study modified at least one of their preferences, and half of the participants in the natural language processing study modified at least one of theirs. Again, highlighting the usefulness of having an iterative elicitation and inspection process. A number of other findings, the respondents said that the tool helps identify agreements and disagreements and results in overall better and increased information exchange among the group. They also said that they would prefer, or that they would definitely want to use the tool for making similar and in some cases even more complex collaborative decisions in the future. So preliminary evidence of utility, grateful to see that. So that was another info dump. Let's have another little question break before we move on to the demo. Interesting user studies, how can this data be visualized? So that is an excellent question. In the supplemental materials to our paper, we actually have everybody's answers, so not just the averages, but we have everybody's answers with the names redacted, obviously. That's a table, so you can represent it using tabular data, and you'd be able to represent it visually using some of the idioms that we've been talking about today. Yep, no problem. All right, any other questions before we move on to the demo? All right, well, let me prep the demo while we've got, just in case we've got some questions. Oops, shoot, that was the chat. Let me bring the chat back. Oops, shoot, there we go. Okay, so there we go. Can everybody see the tool?
Yep, I think so.
Okay, excellent. All right. So the first thing you'll notice is that we took the colors out. And the reason for this is to support scalability, because you can only look at so many colors before you are no longer able to distinguish them. And so using colors as a means of distinguishing between alternatives or evaluators can be quite limiting. But we still do use colors for the purposes of highlighting. So for example, this is, again, completely fictitious set of people, including me, who are rating different hotels. And so I'm going to say that I'm particularly interesting, and so I take a look at my own scores and notice that the color appears. And here we go. So the colors are used for highlighting and also for selection. So now if I want to look at Danielle's, and notice when I hover over one particular mark, so in this case Danielle, all of Danielle's marks show up so that I'm able to see Danielle's scores everywhere. This is an idiom called linked highlighting. It's an interaction. All right, I'm just see. So I think one of the first things I'm going to want to do, I'll just uninterest myself there. One of the first things I want to do when I'm looking at this is I want to see if there are any non-dominated alternatives. Because if there are any non-dominated alternatives, then that means that there's an alternative that everybody seems to like best, and hopefully that means we can all go home. So we can do that here in this compare alternatives mode and take a look at the parallel coordinates plot. And so we take a look at my favorite. My favorite seems to be the MERIDIAN. So that's interesting. But from the crossovers, we're able to see the crossovers represent trade-offs is one way of looking at it. And so the fact that we do see crossovers between my highlighted set of lines and the other lines means that there are no non-dominated alternatives, which is unfortunate, but let's go ahead and just be thorough about it. Bob seems to prefer Days In. It looked like Alice preferred Marriott along with me. Carol seems to prefer Four Seasons. And Danielle seems to prefer the Hilton. And then it looks like Edgar and Francine prefer the Sheraton. So that's a number that are interesting. We may decide that we don't actually want to consider the Best Western or the Travelodge anymore. So we can just go ahead and hide those and just look at the 5 remaining, but I'll go ahead and show those again. Oops, there we go, show them all. Good, so put those back in. All right, so that's the first thing we do, but it looks like we've got a 3-way tie for top, so let's just confirm that. I'm gonna go back into compare evaluators mode, and let's take a look at sorting things by total scores, which we can do. And indeed, we do have a 3-way tie. We can confirm that with the overlays, 41, 41, 41. Okay, so that's fine. So we have this 3-way tie. Well, what should we do now? Well, maybe it's useful to look at variance. So we can go ahead and also sort by variance here. Now, unfortunately, it looks like there's quite a bit of variance for all 3 of our top scoring alternatives. And it looks like the most agreement is about the Best Western, which people tend to score fairly low. So just, no, that's top, my apologies. So maybe we want to be a little smarter about the sorting, and we can do that with a hierarchical sort. So I'm just going to clear all the sorting. And basically we can use the hierarchical sort in order to break ties. So let's go ahead and apply that initial sort by total score. And now let's add in a sort, or a tie-breaking sort by variance. So if we apply that, okay, so it looks like the Sheraton overall has the least disagreement among the 3 top scorers, which is interesting. But there is still quite a bit of disagreement. So let's look into that. We notice that for all 3 cases, we have an outlier. And that outlier, it looks like, is Bob. So let's go ahead and take a look at Bob. Bob's kind of interesting. And let's see, we take a look at Bob's scores. Let's try and figure out, just from what he's got written here. Oh, he's saying that the Sheraton's too expensive. He's saying the Hilton's too expensive. So it looks like price is a big deal for Bob. So that's worth discussing. All right. And we'll come back to that. But let's swap back to comparing the alternatives for a moment. Okay, and go to our alternatives pane. So for now, let's just worry about those 3 seconds. There we go. And it was just those 3, so the Days In, you can unselect that as well. And let's go ahead and hide all the rest. We're just going to look at the Sheraton, the Hilton, and the Marriott, because those are the top scorers. And we'll come back to Bob in a minute. So let's take a look at some of these trade-offs. Now, it seems that I've got a pretty big difference between my scores on the Marriott and the Hilton. But it seems like Alice, not a huge difference between them. Bob seems to hate them all equally. Again, we'll come back to Bob. Carol doesn't seem to make a huge difference to her. Danielle seems to really prefer the Hilton over the other two. Edgar's got a bit of a spread, but not insurmountable. And again, Francine's got a bit closer. So it looks like Danielle and I are the biggest ones, have the biggest disparity in our scores between these hotels. So let's suppose that through our discussions, Danielle comes to the decision that maybe she didn't like the Hilton as much as she thought she did, and she updates her score. I'm just doing that on my other screen here. And there we go. Okay, so it updated on mine, even though it was done remotely. And so now the Hilton's fallen out of favor a little bit relative to the other two. Okay, so that, sorry, I'm just going through my demo notes here. Yep. So let's go ahead and not worry about the Hilton for now. And we'll worry just about these two. And a second, I'm just dealing with something a little bit. Okay, my apologies. So we do the comparison, and yeah, there's still a bit of a difference for Edgar and a bit of a difference for me. And let's say that it's my turn to decide that I'd like to change my preferences a little bit. And again, we can see this happening in real time as we change the score, and we retain the sorting as we go. Let's say that I decide that I really like the Sheraton, and so I'm going to go ahead and increase my score on that, and then I'll go ahead and update my preferences. So it seems that we're getting a bit closer, but we still have Bob to deal with. And just to keep the demo relatively short, let's go ahead and pretend that the finance officer for the company comes in and reminds Bob that the trip's going to be paid for by the company, in which case he'll say something along the lines of, Bob all of a sudden decides that he loves the Sheraton, and now we have quite a bit more agreement on the subject. And then we come to the decision that we will go to the Sheraton. So that was just a quick demo highlighting some of the functionality associated with this tool. Let's switch back to present. Actually, how about I stay in the demo? We'll do one more quick question break before I move on to our ongoing work. Let's clear all the colors. Does anybody have any questions? I lost my chat window for some reason.
There is a question in the chat from Ines Hessler. And also, I just wanted to remind you or point out we're 10 minutes from the end of the webinar. So just
yeah, I'll
keep that in mind.
I'll try and be quick.
Sure.
Okay, so the target audience is both casual users, which is why the default when you open the tool is with the box plots. So casual users, definitely. Also professional users. When you're talking about more complex decision scenarios, ones where you need to include attributes, which obviously this tool doesn't cover, it can still be useful in terms of preliminary discussions. Perhaps people don't understand what attributes are actually important, and so having this preliminary direct scoring method can facilitate a discussion where we figure out what are the attributes that matter. How can you access the tool? Yeah, so we will talk about that at the end. All right. So now let's get this going again. Oh, there we go. Okay. So as I just noted, scoring alternatives isn't always enough. So for the hotel example, I'm not just saying I love Hotel X. It's a matter of, well, how are the amenities in Hotel X? Is the Wi-Fi good? Is the pool good? Is it more important that the Wi-Fi is good or that there be a pool? How's the restaurant? How's the customer service? So we can have not just attributes, but we can have nested or hierarchical attributes. And so we performed an extended scenario analysis to take into account things like evaluators, not all evaluators being as important as each other in terms of making the decision, whether certain evaluators are similar enough that they can be grouped together, and hierarchical attributes. And we're taking into account whether there are no attributes, so we just score things directly, or whether we have subjective attributes, meaning how good or how fast the Wi-Fi is subjectively, and then perhaps objective attributes that have a yes or no answer, like is there a pool, yes or no, or what is the signal strength for your Wi-Fi. Once with these extended scenario understanding, we can have extended data abstractions. So we go from just alt ranks and alt scores to having alt ranks, alt scores, total ranks, total scores, and then the addition of the attributes and outcomes dimensions allows for many, many more measurements to be included. So this example, an alternative attribute score. So we have our evaluators, we have the attributes, pool, and location, and we have some alternatives, Sheraton, Days Inn, and Four Seasons. So perhaps Sheraton and the Days Inn have pools, but they're not heated, and perhaps the Four Seasons has no pool. And so Anne and Bob are in various stages of being kind of okay with a not heated pool, but Carol is heated pool or nothing. So that's one way of being able to look at it. In addition to extended data abstractions, we can extend our task abstractions as well, and we've done that from 12 up to 34 preference inspection tasks. The new one's dealing with various kinds of attributes and weights. The cool thing is that we didn't need to add any new auxiliary tasks. The 10 that we had apply just as well to these additional preference tasks or preference inspection tasks that we found. We performed an assessment of existing tools, and I won't go into a deep one because I don't really have the time, but for example, consensus basically treats everything in terms of subjective attributes, and web value charts treats everything in terms of objective attributes. And our overall finding, which we've, as part of work that we've submitted for publication, we're waiting a response, is that all the tools that we looked at strongly supported some of the visualization tasks, but none supported all of them. And it was also quite interesting that they all seemed to focus on one kind of preference model. Our tool's no different. It focuses on scoring alternatives directly. And so the idea is it would be great if we could have a tool that supported all preference models. And an important step to that is understanding that there are relationships in the data between these preference models. And so we came up with a preference model taxonomy that classifies the preference models in terms of what is being assessed, whether it's alternatives, whether the alternatives are being scored by attribute, or whether they're being scored by the outcomes of the attributes. So what is being assessed? How is it being assessed? So is it being scored or ranked? And are the attributes, if they're there, being weighted? And so what we find is if we look at the data as multidimensional tables, that data transformations allow us to move between these different preference models. So coming up with a design that supports everything works if you can work with these transitions and find idioms that can follow those transitions as well, which is what we are currently working on now. So taking our existing design for our current tool and extending it to be more flexible and accept more preference models. So for example, we take the tabular bar chart where instead of having just a bar for a score, have a toggle where you can split that score into the scores for attributes. And then you'll have a tabular bar chart over attributes instead of just alternatives. Similarly, since we're dealing with more dimensions now, we're going to have a number of, in this case, if we're dealing with strip plots, a number of different circles for whatever the third dimension is. And so having more flexible strip plots that allow us to perhaps have the user decide to aggregate or split that third dimension so that you can look at things in an aggregated way or more in a more detailed way. And being able to augment these strip plots with boxes for distributions or parallel coordinates on demand. Additional optional charts that you can toggle on and off for attribute and evaluator weights, as well as in the case of objective attributes, being able to see a person's scores for what all of the possible outcomes of the attribute were. So sped through that, but our future work is to integrate our visualizations with data and spatial context, because while preference inspection is an important part of group decision-making, it is by no means all of group decision-making. There are many other things to take into account. So integrating these visualizations with other data visualizations, spatial context in a map, for example, can be quite useful in having a more holistic picture to support the group decision-making process. We plan to continue to update our data and task models, not only by examining additional group decision scenarios in case there are new scenarios that give us new insights, but also by incorporating additional models and theories of group decision-making. And also, we plan on taking a closer look at discovering nuances that are not captured by the preference models, because discovering those nuances, I believe, is an important part of the iterative process of elicitation and preference inspection. So there's our references. I've bolded the one for our paper that was published this year in Pacific Viz. And thank you to publicdomainvectors.org for providing free clip art that I liberally used. So that's the end of the presentation. I thank you very much for your time. My email address is on there if you would like to contact me and follow up. We can start off the final questions with Ines's. How do you access the tool, and to what extent can you customize it? So right now I'm working on finishing up the documentation, and we will be posting it on the MERIDIAN, I think, GitLab. I think, well, I'll check with Oliver to confirm, but we will be making it available for download and use. It will be available such that you can install it on your own server and then have whatever questions or decisions you want. If you want to customize it, go ahead. And we will have a version available in a demo mode so that people can play with a couple of sample decisions. Any other questions?
There was one, Jordan, that
Yep.
I missed earlier from, did you address the one from Emelis about the target audience?
I did, yeah. So
you did. Oh, sorry. Yeah, I missed.
Yeah,
that.
no, that's fine. I was kind of going a mile a minute for a part there, so that's fine.
Good. Okay. Well, thanks for speeding up at the end.
Oh, no problem.
Yeah, we'll allow people just one more minute if there is a final question.
Sure.
Okay, I don't see any extra questions. So,
well, if you have some follow-up questions, again, my email address is right there. Feel free to send me an email. Make sure you spell my name right, though, or I won't get the email. And yeah, I look forward to hearing from you.
Thanks, Jordan. And thanks, everyone, for tuning in to this webinar. As the very last thing, let me just remind you that this is part of a series of webinars. So we have more webinars coming up. The next one will be, we'll take a week's break. Next week, there's no webinar, but then the week after, on December 15th, we have a webinar about deep learning and how deep learning can be used to create very powerful acoustic detection and classification algorithms. So something to look forward to there. And as I mentioned at the beginning, this webinar was recorded, and we will make the recording available through our YouTube channel. We'll have it up there in a week or so. And you can find, I think we have the link in the chat for that YouTube channel. And if not, you can find it through our website. So thanks again for tuning in, and hopefully see you in a couple of weeks.